Okay, so in this video I'm going to make these two pieces. I'm not really going to cover the milling of these because it's basically the same as the milling on this piece. But I have to drill and tap some holes, and I use the CNC machine to mark those and spot drill them, and use it. It's all manual using the DRO, and that worked pretty effectively, just locking it into a vise. Tapping the holes, all done manually. Drilling was put on the drill press, and I also have a buffing wheel on here, so after all that I just give it a good little buff, get rid of all any kind of pieces of sharp stuff, and this is how it looks after it's all bolted in place. The Z motor fits in here and goes all the way down somewhere there. This is my Z motor over here on the machine currently. It has a brake, so that's why it's so damn tall. For comparison, where is it? Here's what the X and Y motors look like. So, like that. That's how big this one is. Z motor is just short enough to fit in here without interfering with the bearing carriages and stuff. But I'll be happy when that's finally in place and I can truly verify that the design and everything was all correct. So I'll leave it from here and go through the steps to finish off these parts. Later on in the video, I'm going to go over some of the design considerations I have to take when attaching this ball screw nut housing, and I might visit this a bit more because currently I'm losing a bit of travel. As you can see, this riser intersects with the bottom rail, so I'd like to see if I can get some of that back. So these two are done on the first setup, and now I got to do this side. So I made this pocket, some dog bones for the corners, and then some areas where I can just get under with a screwdriver and lift it up. And I've moved this outwards by 0.1 millimeters. So that should give me enough space so it's not completely stuck in like this other one, where I can pry it out and I won't have to destroy it, because I want to be able to reuse one of them for, I got two to make. So cleaning up the side with a file gives me a reference I can indicate off of. So after the second setup, here's how they look. They are mirrored on both sides, and this is the fixture I put together. So I would just go in like that, and then there's two notches in here, so I can get a screwdriver under it and then lift them up. So that's how that works. What I have to do now is drill a bunch of holes. So on these two faces, series of holes. So what I think I'll do is, to get them perfectly where they need to be, I'll spot drill on the CNC machine, and I'll clamp these in a vise. So I have a small vise here, and to get it lined up, I think what I'll do is I'll mill this flat so it's aligned with the y-axis, and then I can put this up here, and then I should be good enough to then mill or spot mill down the center after I indicate where all the bolts go. There we go in the center. So that's going to be our center point, and then we're going to figure out the bolts from that position. So on this side I got to put in 3 holes, and that looks like over here. So 25 millimeters distance, and it's going to be tapped, so we're going to put in a 4.2 millimeter hole there. Let's get started. Those are 3 holes marked out. So what I'll do is I'll later go on the drill press and drill these out. I'm drilling the holes out on a drill press instead of the CNC machine because it's just I have a lot more control. So that's the setup, and I just run at a low speed. and the depth is locked on here. So I've eyeballed it, so it's going about that deep. I just have to go and drill these sides now. All the holes are drilled, and what I'm doing now is tapping, and I've made a tapping guide with this piece of aluminum here. So this thing just keeps all the threads, everything aligned, and just helps it start so it doesn't pull itself out. Let's get some air in here. So they're all tapped now, and I'm just going to use a drill bit and just take off this burr on the top on all of them. And then these parts are ready to be buffed. So the buffing wheel is right here. All I have to do is change the pulleys. So I basically put this on the big one, put this one on the small one, change the ratio up, and yeah, then I can use this whole thing for buffing the parts. And then it's done. Holes are now cleaned up, and that's how they look. Same on this side. I find a tip when you're doing this stuff, if you're doing a setup like this with a big giant drill bit, if you have a bit of oil on the base, it'll help with the chatter. So all you have to do is basically just go slowly until it centers on the hole, and yeah, just hold it firm, and usually it won't chatter that way. So the left is polished, the right is not. That's what the difference looks like. Here's the Z assembly assembled. Tongue twister. What I'll have to do here on the bearings, the intersection is too much, and I measured these ones and they seem to be the same size and depth as these ones here. So what I'll probably do is face off this side just so the bearings can be bolted down. I don't want to take too much material off because I don't want to reduce this distance too much because it's structurally what's going to make this whole thing stiff. And yeah, that's the old one. What's left to do on this is I need to weld the two angle pieces that are going to hold the x-axis bearing carriages. It's going to be similar to this one here. This one's two pieces of plate steel or bar stock, 1/4 inch. I think 4 inches that way. And yeah, I'll have to make this one probably 8 inches or so just to cover this distance. And I need 2 of those. After that, I should be able to disassemble this and put this one in its place. At that point in time, I'll severely need to double up the Y bearing blocks. So I'm going to build, weld something similar to what I have in CAD to lift this up. I'll move the ball screw and motor onto the outside, which will help with, you know, all the debris and stuff that gets on it. The ball screw for the x-axis is going to stay where it is, and I had the nut housing is there. On the new one, I don't have set in stone what I'm going to do with it, but the L is going to come up and go up like this. So what I might try and do is make a piece out of steel, like a face where the nut can attach to. I have one of those aluminum nut housings, but just the way it all is, I don't think it's going to work that well for me. So either I'll make something out of steel, possibly aluminum, maybe like, you know, 2 pieces of 1/2 inch aluminum, or if I can get myself a chunk of 1 inch aluminum, that would be even better. So back in CAD, here's what it looks like. It's just easier to see everything in CAD than in person. So these are the 2 L brackets, I guess you'd call them, that are going to hold the Y bearings on. And these are going to be steel. I don't want to do them in aluminum just because this whole Z assembly already weighs a ton. And when I put the servos and the spindle on, it's going to get even heavier. And I know if this is out of steel, it's going to be very, very rigid. Somebody else on the Discord is going to attempt to use these nut housings, but I believe what he's going to do is he's going to raise the whole ball screw up even more, and then that way he can build a like out of aluminum, a small little helper piece that the nut housing then bolts onto, and then that thing will then get bolted onto the plate. These nut housings, like if I isolate this, so the threads are on the bottom, which is not ideal for like being able to adjust it. So like when this whole thing is assembled, you have no access to those bolts to align everything. So that would get around having it so you could like thread lock it onto a helper piece, and then that piece then you could thread in or bolt in from the top, and then that's how you could do your alignment with the rotation and any kind of shifting to get it aligned with this whole assembly. What else we got here? These pieces here, let me see if I can just let me isolate them. So what I'll probably do is try and make all this a single piece instead of 2 pieces. The holes here, I don't believe they are the same distance. So 35 millimeters, and then This one looks like it's slightly less. 30 millimeters. So what I might do is have on the top here, have this a plate, and either see how there's it goes down. So I'll probably make a notch for the, well, I'll have to see. I have to see the design. But then what I'll probably do is have it so there's like 2 pillars that go up about there, and then just kind of build this thing out of stacks, unless I can find a piece of aluminum that's, you know, that distance, which maybe at Metal Supermarket they have like small cutoffs that I can get, 35 millimeters. So, and I only need like a small, you know, small little chunk, so that might work. If I have to build this thing of stacks, what I might do is put a notch down, like 0.5 millimeter or 1 millimeter between the plates, so they kind of key together, and then that should stop any, you know, flexing back and forth where, you know, because the bolts are going to be long and they're going to be sandwiching this whole thing together. That way the aluminum itself would keep itself centered, and that way it wouldn't move so much, because moving the whole Z assembly around is that's gonna be a lot of weight, and I might get some movement on the X ball screw BK blocks. And I might look at reducing the distance of here, just because it comes out quite a lot, and I'm losing, like if let me cut this thing in half. So as it stands right now, my rails are this long, and in order to do this, I would have to lose some of the length of my rails, and I'm going to lose some of my X distance. So I might change this, maybe either going vertical or a slight angle or something, or maybe make this side come out more. I'll have to look at this, because I'd like to keep as much travel as possible. So this one especially, it's like I'm going to lose a lot. So that might have a bit of a design change once this whole Z assembly finished. Well, that's what I'm going to do, is get this whole thing. Let me exit out of that. I want to get this whole assembly with the motion control on the ball screw and servo figured out first, and then once I'm happy with that, I will then visit this section back and then see about what I can do to gain more travel. But yeah, fabricate something there, and yeah, then the new Z-axis will be ready, and I can finally, you know, get rid of all this flexing. See if I can get this to flex. It's hard to see, but yeah, this whole thing flexes quite a lot because of the plywood pieces. So I think that covers this video and the updates here. On the next one, I'll probably be welding and cutting the steel to make these two parts. Alright, see you next time.